Good morning. Today our new class is important specifications of op amp. New topic is important specifications of op amp. Okay. Next, recap of this presentation. In previous class we discussed about operation of differential amplifier with the help of a circuit diagram. Operation of differential amplifier with the help of a circuit diagram and block diagram of operational amplifier op amp IC 741. These two topics are completed in previous class. Okay. Next, objectives of this presentation. On completion of this period you would be able to understand important specifications of op amp. Op amp means operational amplifier. So what are the important specifications of operational amplifiers and summary. Okay. So next, important specifications of op amp. So the important specifications of IC 741 are, so first one is open loop voltage gain. So it is nothing but capital A. And second important characteristics of op amp IC 741 is input impedance. Input impedance is denoted by Z in, input impedance. And third important specification of IC 741 is nothing but output impedance. It is denoted by Z0. And fourth one is input offset voltage. Here, so two input voltages V1 and V2. So in case of input offset voltage, V1 is equal, V2 is equal 0. That means input is 0, then output is also 0. That is V0 is equal 0. And next important specification of op amp is common mode rejection ratio. It is denoted by CMRR, common mode rejection ratio. So and next important specification of op amp is nothing but slow rate. And next one is bandwidth. And next important specification of op amp is nothing but input offset current. And last one is nothing but input bias current. These are the different important specifications of IC 741 operational op amp. Okay. So these specifications one by one briefly discussing now. Okay. So in these specifications, the first one is open loop voltage gain. Okay. So what is the definition of open loop voltage gain? The ratio of output voltage to the input voltage without feedback. The ratio of output voltage to the input voltage without feedback is called open loop voltage gain. I repeat once again the definition. The ratio of output voltage to the input voltage without feedback is called open loop voltage gain. It is denoted by capital A. For an ideal amplifier, the gain will be infinite. But practically the gain is more than 20,000. So but practically the gain is more than 20,000. Okay. So mathematically, so the voltage gain is given by capital A is equal V out by V in. Okay. So this is nothing but open loop voltage gain. Okay. And the second important characteristics of IC 741 operational amplifier is nothing but input impedance. It is denoted by Zi. So what is the definition or what is the purpose of using important specification of input impedance? So it is the equivalent impedance of the operational amplifier measured at either the inverting or non-inverting input terminal with the other terminal connected to the ground. I repeat once again this point. So input impedance Zi It is the equivalent impedance of the operational amplifier measured at either the inverting or non-inverting input terminal. So with the other terminal connected to the ground, you can choose any one of the input terminal. Okay, other one goes to connected to output. Okay, in case of ideal value of input impedance, Zi is equal infinity. Units are ohms. Zi is equal infinity ohms. But in case of practical value of input impedance is nothing but 2 mega ohms. 2 mega ohms. Okay, so ideal value of input impedance is nothing but infinity ohms, and practical value of input impedance is nothing but 2 mega ohms. So this is nothing but the input impedance Zi. And next specification of IC 741 op-amp is nothing but output impedance. Output impedance, it is denoted by Z0. Output impedance is denoted by Z0. So what is the functioning of output impedance? It is the resistance measured between output terminal of the op-amp and ground. It is the resistance, so it measured between the output terminal of the op-amp and ground. Okay, so I repeat once again, output impedance Z0, it is the resistance measured between the output terminal of the op-amp and ground. Okay, so this is nothing but the output impedance Z0. And next specification of important specification of IC 741 operational amplifier is nothing but input offset voltage. Input offset voltage, it is denoted by VIO. It is denoted by VIO. So what is the functioning of input offset voltage? It is the voltage that must be applied between the two input terminals of an op-amp to nullify the output. I repeat once again this point. It is the voltage, input offset voltage VIO, it is a voltage that must be applied between the two input terminals of an op-amp to nullify the output. Okay, that is nothing but input offset voltage. Okay, and next important specification of IC 741 op-amp is nothing but common mode gain. Common mode gain, we know common mode signal and different mode of signal. Okay, so then here the specification is nothing but common mode gain. So what is the definition and what is the functioning of common mode gain? It is a gain of an op-amp when the input signals to the inverting and non-inverting terminals of op-amp are in phase and equal in magnitude. In phase and equal in magnitude. Okay, I repeat again this point. Common mode gain, it is the gain of an op-amp. It is the gain of an op-amp when the input signals to the inverting and non-inverting terminals of op-amp are in phase and is equal in magnitude. So gain is simply, gain is nothing but capital A. Here common mode gain is nothing but it is denoted by ACM, capital ACM. So what is the definition of gain? So we know the definition of gain. So it is the ratio of output voltage to the input voltage. Same formula is used here also. Okay, therefore ACM is equal V out by V in. That is equal, V out is same, only 1 V naught by, so V in is different because in this case, so two different signals are applied at the input side, that is inverting and also non-inverting terminal of differential amplifier. Okay, so here V in is equal V1 minus V2. Okay, substitute V naught is equal V naught and V in is equal V1 minus V2 values in this common mode gain formula. Therefore ACM is equal V naught by V in is equal V naught by V1 minus V2 when V1 is equal V2. V1 minus V2 when V1 is equal V2. Okay, this is nothing but common mode gain. This is nothing but common mode gain. What about differential mode gain? What about differential mode gain? So it is the gain of an op-amp when the input signals applied at both input terminals of the op-amp, that is inverting and non-inverting, having equal in magnitude but opposite in phase, that is nothing but 180 degrees out of phase. Okay, I repeat once again, differential mode gain. Differential mode gain, it is a gain of an op amp. It is a gain of an op amp when the input signals, it is a gain of an op amp when the input signals applied at both input terminals of the op amp. It is a gain of an op amp when the input signals applied at both input signals of the op amp. Both input signals means inverting and non-inverting terminals of an op amp having equal in magnitude. Magnitude is same. Magnitude is same, similar to common mode gain, but phase but opposite in phase, that is 180 degrees out of phase. Okay, so next, it is denoted by A, capital AD. It is denoted by AD. So A means gain. Here differential mode, that's why, so it is AD. Okay, we know the definition, we know the formula for gain. So what is the definition of gain? So it is defined as the ratio of output voltage to the input voltage. Here output voltage is same, that is nothing but V0. So but input voltage is difference because we can apply two inputs, inverting and non-inverting of differential amplifier. That's why, so difference between these two input signals, that is Vin is equal V1 minus V2. Substitute V0 and Vin values in this differential mode gain equation. Okay, so therefore AD is equal V0 by Vin is equal V0 by V1 minus V2, where V2 is equal minus V1. But in case of common mode gain, V1 is equal V2, but differential mode gain is nothing but V2 is equal minus V1. V2 is equal minus V1. Okay. If no external input signal is applied to the op amp, if no external input signal is applied to the op amp at the inverting and non-inverting input terminals, the output must be 0. Okay, so this point is important point, note down. So listen carefully. If no external input signal is applied to the op amp at the inverting and non-inverting input terminals, then the output must be 0. Okay, so thus that is the output must be 0, that is if Vi is equal 0, then V0 is equal 0. If Vi input is 0, there is no current flows through the circuit, that's why output also 0. Okay, so this is known as input offset voltage. This is known as input offset voltage. Okay, so this is the input offset voltage. So what is input offset voltage? If no external input signal is applied to the op amp at the inverting and non-inverting input terminals, the output must be 0. That is, if input is 0, so we cannot apply the input. Okay, so that's why input is equal 0. If input is 0, then output 0, because there is no voltage applied to the circuit. Okay, this is known as input offset voltage. This is known as input offset voltage. Observe this figure. This is the op amp. So op amp accept two inputs, positive and negative. So negative is nothing but inverting, positive is nothing but non-inverting. So there is no input here. So input side, input is 0, that is connected to ground. That's why Vi is equal 0. Then output is 0. Then output is 0. Okay, this is nothing but the input offset voltage. This is nothing but the input offset voltage. And next important specification of IC 741 operational amplifier is nothing but CMRR. CMRR means common mode rejection ratio. Common mode rejection ratio. What is the definition of common mode rejection ratio? It is defined as the ratio of the differential voltage gain. So differential voltage gain means it is denoted by AD to the common mode voltage gain. Common mode voltage gain is denoted by ACM. Okay, so I repeat once again the definition of CMRR. CMRR means common mode rejection ratio. What is the definition of CMRR? It is defined as the ratio of the differential voltage gain AD to the common mode voltage gain ACM. Okay, mathematically it can be expressed as CMRR is equal differential mode gain of AD by common mode gain ACM. Therefore, finally, CMRR is equal AD by ACM. AD by ACM. Observe this equation. CMRR is expressed in decibels. CMRR is expressed in decibels. What is the formula for decibel equation of CMRR? Then CMRR in decibels is equal 20 log 10 base 10. 20 log 10 base 10. Okay. Then CMRR is equal 20 log 10 base 10. Okay. This parameter indicates the capability of the op-amp to reject noise. This parameter indicates the capability of the op-amp to reject noise. The CMRR is the ability of a differential amplifier. The CMRR is the ability of a differential amplifier to reject the common mode signals. To reject the common mode signals. I repeat this point again. We know the formula for CMRR. CMRR is equal AD by ACM. Okay. So this is the general formula. So CMRR, but CMRR is expressed in decibels. But CMRR is expressed in decibels. That is CMRR in decibel is equal 20 log 10 base 10. Okay. So this parameter indicates the capability of the op-amp to reject noise. The CMRR is the ability of a differential amplifier to reject the common mode signals. To reject the common mode signals. Okay. In this equation, the larger the CMRR, the better differential amplifier. The larger the CMRR, the better the differential amplifier is at eliminating common mode signals. The larger the CMRR. Observe this equation, CMRR is increases, then common mode gain is decreases. That means it can be eliminated. Okay. So ideal value of CMRR is infinity, but in practical value of CMRR is 90 decibels. The ideal value of CMRR is infinity and the practical value of CMRR is nothing but 90 decibels. 90 decibels. So this is nothing but common mode rejection ratio. This is nothing but common mode rejection ratio CMRR. Okay. And next slow rate. Next important specification of IC 741 op-amp is nothing but slow rate. What is the definition of slow rate? It is defined as the maximum rate of change of. Rate of change of means d by dt. Okay. So the maximum rate of change of output voltage with time. It is expressed in volts per microseconds. Units of slow rate is nothing but volts per microseconds. Okay. I repeat once again the definition of slew rate. It is defined as the maximum rate of change of output voltage with time. So it is expressed in volts per microseconds. Okay. Mathematically it can be expressed as slew rate is equal dV naught by dt. dV naught by dt. Okay. Observe this equation. The slew rate of op-amp is a measure of how fast the output voltage can change and is measured in volts per microseconds. Observe this. The slew rate of an op-amp is a measure of how fast the output voltage can change and measured in volts per microseconds. Okay. If slew rate of op-amp is 0.5 volts per microsecond, it means that output from the amplifier can change by 0.5 volts. Okay. I repeat this again. If the slew rate of an op-amp is 0.5 volts per microsecond, it means that the output from the amplifier can change by 0.5 volts. Okay. I repeat this point again. The slew rate of an op-amp is a measure of how fast the output voltage can change and is measured in volts per microseconds. That means volts per microseconds. If slew rate of an op-amp is 0.5 volts per microseconds. It means that the output from the amplifier can change by 0.5 volts. This is nothing but slew rate. Okay. And next important specification of IC741 operational amplifier is nothing but bandwidth. What is the definition of bandwidth? The frequency range over which the voltage gain of the amplifier is above 70.7% of its maximum output value of the operational amplifier is called bandwidth. Okay, I repeat again the definition of bandwidth. What is the definition of bandwidth? So it is defined as the frequency range over which the voltage gain of the amplifier is above 70.7% of its maximum output voltage of the operational amplifier is called bandwidth. Okay, and next important specification of IC741 op amp is nothing but input offset current. It is denoted by IIO. Input offset current, it is denoted by IIO. What is the definition of input offset current? The algebraic difference between the currents entering into the inverting and non-inverting terminals of op amp is referred to as input offset current. The next important specification of IC741 op amp is nothing but input offset current. It is denoted by IIO. What is the definition of input offset current? So it is defined as the algebraic difference between the currents entering into the inverting and non-inverting terminals of an op amp is referred to as input offset current. Okay, so it is defined as the algebraic difference between the currents entering into the inverting and non-inverting terminals of op amp is referred to as input offset current. Mathematically, input offset current is expressed as IIO is equal, so modulus of IB1 minus IB2, when output voltage V0 is equal 0. Mathematically it can be expressed as IIO is equal, so modulus of IB1 minus IB2 when output voltage V0 is equal 0. Okay, this is completed. And next important specification or last important specification of IC741 operational amplifier is nothing but input bias current. What is the definition of input bias current? The average of the currents that flow into the inverting and non-inverting input terminals of the op amp is called input bias current. I repeat once again this definition. It is defined as input bias current, it is denoted by IB. So it is defined as the average of the currents that flow into the inverting and non-inverting input terminals of the op amp is called input bias current. Okay, so IB is equal IB1 plus IB2 by 2. IB is equal to IB1 plus IB2 by 2. Okay, observe this figure. So this is op amp. So it accepts two inputs, positive input and negative input. Positive is nothing but non-inverting input and negative is nothing but inverting input. It accepts two currents, IB1 and IB2. So both inputs are connected to ground. That means there is no current flows through the circuit. Then output is 0. Okay, so this is nothing but mathematically it can be expressed as IB is equal to IB1 plus IB2 by 2. IB is equal to IB1 plus IB2 by 2. Okay, so this is the input bias current. Okay, so important specifications of IC741 operational amplifier is completed. And next, summary of this presentation, we have seen important specifications of op amp IC741. Okay, and next frequently asked questions may be asked. The first question is nothing but The first question is nothing but define slew rate of op amp. Define slew rate of op amp. Okay, and another question may also be asked, define CMRR of op amp. Define CMRR of op amp. And next question may also be asked, define differential mode gain. Define differential mode gain. And next question may also be asked, define common mode gain. Define common mode gain. So and next question may also be asked, write short notes on input bias current. Write short notes on input bias current. And next question may also be asked, define input offset current. Define input offset current and write the equation of input offset current. And another question may also be asked, so define bandwidth. Define bandwidth. And next question may also be asked, write short notes on common mode rejection ratio. Write short notes on common mode rejection ratio. And another question may also be asked, what is the functioning of input offset voltage? What is the functioning of input offset voltage? And another different question may also be asked, what is the function of output impedance? What is the function of output impedance? And another question may also be asked, so what is the functioning of input impedance? Or write short notes on input impedance. Write short note on input impedance. And different questions may also be asked in today topics. Okay, so today topics are very important topics of all definitions, equations also. Okay, prepare well. Any doubts? Okay, thank you.